system, and to check my system, they've eventually remembered RREF. They remembered where to find it, and where did you find it? Second, inverse, math, and then we need, oh, it's all the way down. Sorry, there's way more than I expected. There we go, B. But wait a minute, don't you have to put something into it? Oh, go back to matrices. So second and then the inverse button or reciprocal button. And then what? Enter, yeah. So that first column is how we get the names to put into stuff, like all the math stuff for matrices. And then all you got to do is hit enter. And then it says, if possible. It says, if possible, I'll give you the identity and all the solutions. So guys, why was BC able to be like, yeah, you're good? Because they did it, and yeah, it was good. Yeah? This time it's a true part calculator, part not. Because I do want to make sure you know how to use it, but I also need to make sure you can do some stuff by hand. Does that make sense? And wait, wasn't homework kind of interesting last night in that, for those of you that started it, I know it's not due until tomorrow, but when you started it, weren't there some things where they weren't even asking for the final solution? They were just asking if you could do the next step?
Yeah, they would.
Right? Like those ones with the shaded boxes. I'm trying to get them in here so we can see it. Any of the ones where, is it the next page? Yeah, this whole section is awesome. Yeah. Because you can't do that in your calculator. Well, you can, but it would be way harder than just understanding the math. Can we peek at one of these just in case someone hasn't gotten to the 30s yet? For number 33, is this in RREF form? No, so you couldn't just put RREF in your calculator. Well, wait a minute. Could it be in REF form? Did you guys notice when you were doing the matrix thing? All right, focus. That there wasn't just RREF, but there was also REF. Ooh, did you also see row swap, row add, row multiply and add? These are the row operations that we've been doing to the R1s, R2s, and R3s. But we're not going to use the computer for that. I mean, we could go back and double check that one of our steps was right. We could try to swap the rows. That's pretty I don't know. I feel like that's pretty easy as far as whatever, just swap them. But if you're trying to add 2 rows, multiply 2 rows, you might want to learn those functions to check your steps. But I was trying to say, hey, there's an REF also. So maybe this guy would be in an REF. If you go get matrix A. REF says I can get you the ones, but I'll leave these guys up top. But the problem is I don't think I would normally want to go to REF when RREF is an option, because RREF says here are the X, the Y, the Z, the W. Here's the answer. This one says you got to plug in stuff. Why am I saying that? Could you maybe, for those of you that were like, can we use a calculator, could you maybe put this in and try REF and maybe get it right? Yes. Could you do RREF? No. So what's easier than either of those? Figure out what they did. Guys, if there already was a 1 and they just got a 0, how would they have gotten a 0? By multiplying R1 by what? -2, right? That's exactly what we did yesterday. Multiply wherever the established 1 is by the opposite of what's there and then add. So -2 plus 2 is 0. -8 plus 10 is, you couldn't have done REF. It would have gotten a 1 and a 1. You wouldn't have known what the answer was. And then double check what's -6 plus 5, -1. We got it. These questions are awesome, and some of them, well, at least 1 or 2 of them will be on the test.
Wait, can your calculator solve for that?
Well, the problem is you would need to know what to do. So you could have put this into your matrix, and then you could have used these little guys. Sorry, my pen. Let me get rid of that. You could have solved for second math, second inverse, reciprocal, however you want to say it. You can have it add or multiply, but wouldn't it be way easier just to do it by hand?
No, but I mean if you put an X for the swap.
Oh, I wish. Because you would have to put in one and then put in another and then have the computer analyze. I mean, I'm not saying that no computer could. I'm just saying because there's artificial intelligence that could figure it out. But as far as your calculator and programming. But the nice thing is it's going to definitely follow your system in the sense of it's either getting 1s or it's getting 0s. 1s you're going to divide, 0s you're going to add, the opposite. Okay. Sorry, I have homework out just in case someone has gotten stuck, but we need to finish notes first. So, my homework people that are talking, just keep it more to a whisper and less of a talking out loud. And then my people who have not yet gotten into homework, let's just finish a few more sample problems. Whoa, whoa, whoa. Do you guys see how far I am? I'm in the 60s, yeah? So I'm trying to get towards the end of homework and try to figure out if there's anything else I can help with or anything. Ooh, that's just about your calculator. Or anything else that, ooh, hey, you know what? That whole row swap, row add thing, I've given you right out of the TI manual what you might need to know if you ever were curious. Not that you have to know it, but if you're ever curious. So, coming back really quickly, what's going on in the 60s in your homework? What's it saying to solve with? Substitution. Nah, that was chapter 7. Elimination. Nah, that was chapter 7. Yeah. So can't we just make a quick little like, oh, whatever. This is easy. I sometimes do a solid line instead of a dotted line. A, because I'm lazy, and B, because it's another way of doing it. It's up to you. But if I was to use matrices, I would go ahead and do negative 2 R1 plus R2. Negative 2 times 1 plus 2 is 0. Negative 4 plus 1 is negative 3. Double check my math. Let me know if you disagree. I'm just practicing RREF, and you're like, well, that's dumb. Why am I doing RREF? Pause. Take a step back. Realize it's a skill we're trying to develop. Wouldn't you rather practice it on a little one than on a big one?
Maybe.
Would you rather me give you lots of big ones for homework, or are you okay practicing on a little one? Be thankful for the little one. We just had a 4-variable one. That was nasty. Be thankful for the little one to practice on. But here's my question. We already practiced in that homework-ish question with the box we were trying to fill in how to make a 0. Can we review how to make a 1? Why am I asking that? Where's a 1 supposed to go? I want that to be a 1. So do I add, multiply, divide? So am I going to divide by? What's that?
Negative 1/3.
Negative 1/3. R2 into R2. So wouldn't negative 1/3 times 0 be times negative 3b and times negative 60? Question. Could I be done?
Yes.
Because, what do I know about y? I could do stair step and be like, hey, I know that 1y equals 2, 1x plus 2y equals 7, and I could plug in. But that was Gaussian elimination, just row echelon form. Gauss-Jordan says, go the extra step. What would the extra step be? Well, you could back substitute, but the extra step says, don't stop, go one more. Go one more means get the 0. So how do we get the 0? You see it? It's definitely a systematic approach. There's definitely a procedure to this. How to get 0s, how to get 1s, and just repeat over and over and over again. This guy's going to stay the same. We already know y is 2, but maybe even faster than back substituting, especially since you're in matrices anyway, is just to say, okay, 0 plus 1, sorry, negative 2 times 0 plus 1. Negative 2 plus 2 is 0, and negative 4 plus 7 is? I think that was easier than back substituting if you're already in the matrix mode. Does that kind of make sense? Because now I'm done, and I know x equals 3, y equals 2. This is a consistent one-solution system. Now, would elimination have probably been easier at the very beginning? Yes. But I'm having you practice on a little one. Does that make sense? Because remember, yesterday, most of us came to the conclusion we might not have been in agreement after seeing all the numbers. Come on, it looks kind of cool. But did we really want to go eliminate x's, eliminate x's, eliminate x's, eliminate y's, eliminate y's, eliminate z's, eliminate? I mean, maybe.
It looks like just as much work. Like the work looks the same, to be honest.
In some ways it might be, I understand. Yeah, so in some ways you might prefer the other. I'm a lazy person and I wouldn't want to write the x's, y's, and z's. In my mind, this is writing less. But you're right. You're right. For some, especially for whom mental math is kind of a chore, they might be like, can I just do it the other way, please? I think I'll get there eventually. So that's why I was asking, because some, yeah, you're right. I feel like some do prefer the other way. Sophia.
So on the test, will we be given the option to do matrices or
Here's the problem. What's the title of chapter 8? So I'm going to have you practice your matrix math. Now, remember, all of this is kind of still getting you towards the, yes, there are tools, there is technology, but matrices are kind of showing you that even though in section 7.3 it was like, okay, elimination, okay, what do we do? Okay, let's change it up. There was a lot of creativity in 7.3, even though we did a system. Matrices shows you a little bit more. No, like literally, there is a system that will always get you to a solution if it exists. It's kind of getting you closer and closer to programs that could take anything that's given to it and solve for the solution, no matter how difficult the math could be. Does that kind of make sense? Kind of like a computer could tell you the solutions of a quadratic without thinking through, like, hey, is factoring better? Is completing the square better? Is square roots better? Like, the computer's like, give me the quadratic formula. But for this, there is no quadratic formula that will always get you to the answer, but there are matrices that could always get you there. Does that kind of make sense what I'm trying to show? So what's weird about these guys, and why do I have them both up here as like, so what if?
Because the one has three with two variables and one is non-square.
Yeah. If you were to go plugging this into your calculator, this would be a 3x3. Wait, I thought we wanted a 3x4 or a 2x4. Wait, I thought we wanted a 3x4. If we have two variables, usually 2 is enough. Or if we have 3 variables, we need 3. So can you guys, now that you've learned how to use RREF, can you put these in and let's see what happens? What happens if you put these in as they are to your matrix math and use the RREF feature? Because something's weird. Your brain would tell you something's weird. What's the calculator going to do that's going to tell you something's weird? And how do we use that to still get a solution? This is partially learning how to use our tools and partially thinking through how are we going to approach this problem. Trying to make it so you guys can see it. Can we make it like there? Is that okay? I think we have it.
So that would be a 3x3, right?
Yeah. I wonder if a 3x3 works. Because this one, the other one had 3x3 for the variables and then that extra column. This one, does negative work? No, negative doesn't work. Okay, just going for the first one. Is that helpful? Does that tell me anything? I just did 71. Is that good or is that bad? It tells me x is 0, y is 0, and z is nothing, but there's a 0 is 1. Like, all it did is say, oh, sweet, you gave me a square matrix. I'll make it an identity. It made it an identity. We're like, great, but we wanted the answers. See how that's bad? It didn't understand what I gave it because here's something for you guys to realize. REF and RREF, we haven't specifically talked about it. Priyanka's question kind of did. REF and RREF need augmented matrices. Now here's the problem of augmented matrices. Augmented matrices need to be a square matrix. I'm just going to put square because it could be 2x2, 3x3, 4x4. I need the square matrix, 2 equations, 2 unknowns, 3 equations, 3 unknowns, 4 equations, 4 unknowns. I need a square matrix augmented with something else, or else my REF and my RREF won't work, which is a bummer. Meaning, it's illegal for this RREF. It's impossible for the calculator to solve this the way it's written. Now, hold on. We're humans. We're creative. We can maybe solve this. But a few of you guys, if you were creative, you might start playing with, okay, wait a minute. So the calculator can't do a 3x3. How could I put this exact same information in and make it a 4x4? But where would you put a 0?
In the third column.
Why the third and not the fourth?
Because
The z's are missing, yeah. So we could think about this maybe as having like z's of zeros. You guys can start playing with that and see if it works or not. And as you do, as you go like, okay, well, I mean, there are no z's. I guess I could put zeros for z's and then it's legal because it's square. As you guys play with that, let me play with the actual math. The actual math says whatever. I don't need a matrix. So if I don't need a matrix, what would I actually do? Well, let's do elimination. Elimination's not bad. So I'm going to take these two down over here. So my equation, technically my equation 4, would turn into negative 3x plus 3x is 0, 3y plus 4y is 7y. Negative 66 plus 4 is negative 62. So y would equal negative 62 over 7. Now you could go ahead and say, you could be a little dubious. You could be a doubting Thomas. You could be if it gave me a next equation, I wonder if it still works, because if it doesn't, maybe it would fail. And you could try to multiply by 4 and negative 3, or you could try to do like the first and the third. Since you're a human and you're creative, you can multiply him by 4 and say, I wonder if it works for this guy too. So then I have negative 4x and 4x is 0. 4 minus 8y is negative 4y. And I have negative 88 and 32, which would be negative 56. Uh-oh. How's this looking?
no solution.
Why is it no solution? Why are there two different things? That doesn't work. Now hold on. What happened when you guys tried? I'm not saying it's always no solution. It's possible. And the intersection point of these two and the intersection point of these two is the same. It's possible. If you throw 3 random lines up there, it's not very probable they all intersect. What happened when you guys tried to do RREF with this guy, though? Can 0z equal 1? Can 0x, 0y, 0z equal 1? No. This one, you can't see that it's impossible. This one, you can. This one was actually a little illegal. RREF just says, I'll make the identity. Yay! You're like, it didn't tell me anything. This one says, I'm trying to do that row echelon, that reduced row echelon. Uh-oh, something failed. Something failed tells you these do not all intersect. Sophie.
I have 2 questions.
Yeah.
One, if you're concerned about being no solution, because it looks kind of weird here, couldn't you just plug in a random point and just discount it from there? It's no solution.
I wouldn't plug in a random point because remember, the solution to a system isn't what point works, it's what point works in all of them. Does that make sense?
Yeah. Also,
P.S. Start playing with how you're going to put that one in your calculator, thinking about what we did with that one. And also,
could you subtract an equation like just as it is and then get 2 equations? Or is that not?
Yeah, you could.
And then plug in.
Like you could join those two, join those two, and then think elimination. Yeah, you could. That would be legal. That's you like condensing the information. Yeah, that's legal. That might have even been simpler than what I did. Or what might have even been easier is just solve for y. Negative 22 plus x, plug it into both. To be honest, in hindsight, that might have been easier also. Those of you guys that are throwing this in your calculator, what are you thinking you should do?
I'm very confused.
Do zeros for the bottom one?
Yeah.
Get rid of z. Oh wait, never mind.
Well, since we're using matrices, how do we put it in a way that the calculator understands the RREF feature? I have 3 unknowns. I need it to go 3 down. So if I don't have, I can add in a 0 column and make it legal in my matrices, or I can add a 0 row. And the question is just, what do you get and whether or not it's false? And if it's not false, what does it mean? If it is false, we're done. No solution. So now we have a 3 by 4 again. Okay, so you guys are doing R, R, E, F, and what happened? What do you guys think? Hey, that's not a false statement. Is that good?
Yes.
Okay, so if it's not a false statement, how can we use, and we could have done this by hand. We could have done R, R, E, F. I'm just trying to, now that we've learned how the calculator works, what would happen if we had done it by hand. That ends up with 1x minus 5z equals, you guys have it still? Can you read it off to me? Equals what? 4. 4? Then what's the next line?
1y plus 9z equals 1.
Now here's the weird thing. Do you guys realize this is in reduced row echelon form? Doesn't look like it, but it is. Why? What's the very first coefficient that you come to in each row? Check. In each column, what else is there? If the 1 is there, what else is there? Zeros? Yes. Zeros? Yes. 0? Wait, I don't even think about this column. There's not a 1, so they don't have to be zeros. It's actually in reduced row echelon form. It's impossible to get any closer to the identity matrix. This is one of those weird exceptions. But pause. What just disappeared and actually was never there? I have my 1x. I have my 1y. What's missing?
Z.
What do we do when z goes missing?
A.
Got it. This is one of those infinitely many solutions. Plug in the a. Does that make sense? Does it make sense how the calculator showed you that? And does it make sense how this is R, R, E, F? The first coefficient in every row is 1. Wherever there's an established 1, the rest are zeros. He doesn't have a 1, so he can't have zeros. We're done. We're not done. We have to now interpret the answer. But yeah, sometimes you're going to do more than the calculator's going to do because you have to take what it gives you and say, hey, that's as far as you can go. I'm a human. I can go farther. You want in and out right now?
No,
Oh, you're going in and out.
Field trip to Mount Atkins now.
You guys should go to movie night and you can get Chick-fil-A while watching a movie.
Good plug. Suppose
No,
there's going to be
in
like
and out.
cornhole and temporary tattoos and no, what else to keep you busy until the movie. Although to be honest, I haven't seen Toy Story 4. I should like sneak into the middle school. I heard it. See, Toy Story 3 was sad. When I heard Toy Story 4 was more sad, I was like,
Toy Story was funny.
exactly.
But it was funny too. Like Kaboom. Oh my god.
Oh.
The
Maybe we'll sneak into the middle school.
Me and Sherry will get in and out right now.
Yeah. Okay, so, I mean, technically you have that option, but. Hey guys, in your calculator, whether you have an 84 or whether you have an 89, not any of you have to. I do kind of have, like the pre-cal graphing handbook, I do have the matrix stuff that you could do. For instance, you could actually kind of like type this whole thing in the beginning of the calculator, hit the still button and put it in A, even though that would take way more time, I think. That still button's actually pretty cool. There's different things that you can actually use the calculator to do these steps that you're doing, so you can check your step, not just like the final answer. If you check the final answer and you're wrong, you're like, well, great, where did I go wrong? You could use it to check. It's just, I don't know, I think it takes more time to actually try to add 2 rows, multiply 2 rows, than just checking it by hand. But anyway, it's a thing. I put it into your notes. It'll be saved in the PDF. Ooh, but this is the one that you want to see the most, is what we've already figured out. REF versus RREF. But check in. Check in. What's going on in this special case that's actually in the TI manual? How are these in RREF form or REF form? Yeah, there's no identity matrix, but what ended up happening? So how many solutions are there to either of these matrices? Infinitely many. What are we going to have to do with z when we actually go to write it out? Let z equal a is how we're going to do it. I mean, the book could choose x to equal 2a for some random reason, like they did before to make it look nicer. But yeah, we could let z equal a, and we could go ahead and solve this solution. But what's the difference between these two? Remember, RREF says get the ones if you can. Get zeros everywhere else. REF just says get ones and zeros below, ones and zeros below. Everybody else can stay the same. So ironically, these could be the exact same system, just written in 2 different forms. Just a reminder of what the calculator does and what the calculator cannot do. If it's not a consistent solution or system where there's only one answer with one X, one Y, one Z, we have to be the ones to come behind and interpret the technology. Humans are necessary even though we have computers? Thank goodness. So, to end off class today, and to end off the example, we have a few minutes. Got them before going to section 8.2, which we might introduce if you guys finish this quickly enough. What do I want you to do? Solve it. Using matrices by hand. You can check with your calculator. Ooh! Some of you have to put your calculator down. You can solve it by hand and check it with your calculator. But what's nice for you guys? What was the size of the one we did yesterday? It was a 4x4. As far as 4 equations, 4 variables, it was technically a 4x5 matrix, right? 4x4. What size is this one?
Oh, 3.
A 3x3. And I'm giving you a whole 2-minute head start. But then I'll start crunching my numbers.
Oh, I get a race.
We know.
I'm gonna race ish. I'm giving you guys a handicap.
I need one.
Oh, you want me to just go? No, you guys will race. Some people are still writing down the problem. We'll get
I'm still
Yeah.
Give you time to get it down and get started, and then I'll start playing. So hopefully then your attention will be down on yours instead of up on mine. And your gosh, I love this stuff. Oh.
They pop it off.
Don't do that. It's all about matrices.
That will be easy for substitution and stuff like that. You can learn it.
Not the question. Not the problem.
Why did you give us a fraction?
Ooh, cheese pizza. I did that for this tea.
Gotta start somewhere.
I've slept after slept too. It's really nasty with all fractions.
Can you hang in there? When the going gets tough, do you give up or do you get going?
Depends on what the going is. Yeah, like math, I just kind of like throw in the towel and pass it.
That's why I'm trying to challenge.
Well, I got the first time.
Remember how we did yesterday? When you have fractions, just think about everything in terms of fractions and common denominators, yeah? And look, you already have a 0. I was so nice.
Thank you.
I was really good. Technically, I didn't make the problem, so maybe I'm lying. But there's some.
Negative 7 times 0, 1 plus 4, 3.
Oh. 7 halves and negative 10 halves. Negative 21 halves and negative 84 and 6.
What's yours next year?
Thursday. Tomorrow.
Tomorrow?
Wednesday.
Friday. That's away. It's at Chavez High School.
We're playing like our game is even on the schedule. Like, you
It's just
know?
like random.
No, it's like it's on Max Preps, but like she printed the schedule and she gave it to us, and it's not on it. They're like,
Who's it against?
Verno Heights Academy.
Hey, party poopers.
Yeah.
How you doing?
Terrible. How are you?
I feel that.
Hey, maybe I shouldn't ask how you're doing. How's the math going?
Great.
No, the math can be awful. I'm hoping you're not awful just because the math.
Oh, I'm just kidding. I'm just slow.
Okay.
The subject at hand reflects my mood.
Hopefully you're double checking my math and not just trusting Ah.
What's 7 times 12?
Who's backing me up? Anybody? Pause. Double check. Anybody back me up yet?
Oh, heck. I'm so confused.
Caitlin, how are we doing so far?
Trusting your degree.
Caitlin goes fast. She's probably already done it.
What? I'm getting confusion.
Same thing so far?
I'm getting confusion.
On what step, Al?
On the one you're doing right now. I don't know how to.
Well, remember, I have my 1, so I'm trying to get 0, so I have to multiply this guy by the opposite. So I'm going to multiply by a half, so it adds to be 0. And I'm going to multiply by 3 halves, so I add to be 0. See it? The nice thing is, anything times 0, this first guy just adds to be the same. And I made it so that these guys are zeros. I just need to figure out what the other guys are. So I have 1 half times negative 3 halves. Negative 3 fourths plus 6 fourths is 3 fourths. I always think in common denominators. I like it a lot easier. And I have 7 halves and 24 halves. 7 halves and 24 halves would be 31 halves. Negative 9 fourths and negative 42 fourths. Negative
42.
Negative 51. Negative
That's
9
so
fourths and negative 42. Negative 51 fourths. And 21 halves. 21 halves minus 156 halves would be negative 135 halves. I'm really hoping some of these fractions start to go away right about now, because I have to multiply this guy by negative 4 over 51. 0, 0, 1. Ooh, that's nice. And that ends up being 270 all over 51.
Everybody needs to list they still have initial work.
On which one?
On the 1 half by 2, on 3, 2, I got 2, yeah.
What's she?
Negative 17. Negative
Or actually, I got negative
14.
2 on the first one.
Okay,
Yeah, there. That's where I got it.
Negative 14 minus 5.
I don't know what I did.
Ooh.
Jeez, gonna be long.
No, you're right.
I think this could
I didn't feel good.
be shy.
Negative.
Jay will shoot you.
Positive 7 halves minus.
Indeed.
No, I'm right. Sorry.
Wait, why is it?
It'd be positive 7 halves minus 10 halves, which would be negative 3 halves.
Ow. Negative 2?
Yeah. Because it'd be negative times a negative is a positive, so positive 7 halves minus 10 halves is negative.
How many passes? I get 3.
Hold on, something went
How many
funny.
passes do you need?
I think it was my 156 one.
156.
Is it positive?
Well, I got him put it.
135?
Is it positive 125? That'd be nice if it was.
Or, no, yeah, you're right.
So it'd be 3 halves, which is 21 halves, 21 halves, minus 156. Is it right? Negative 135.
You work
Yeah.
there? It's fine.
So far, so good? All the way?
Yep, I made it
Caitlin,
all the
you
way
too?
without any issues.
Sophia, you're reading?
So far. Oh, wait, yes.
Because then we would end up with, I believe, negative 4 over, that reduces to be 2. 2 and 135 is 270 all over 51, which is kind of messy. Hold on. If you're starting to get scared right about there, what could you do? What did I say you were allowed to do?
Kill fractions.
Check.
Fractions are not people.
So we have our 3-4 efficient not proof. Efficient not
Fractions are proof.
proof. Okay. We could throw this guy in and we could see if this 2/7/51 is actually true. I'm going to go ahead and do that to finish the video today. You guys have homework due tomorrow. I was just doing a harder problem and this kind of, I know, fractions get messy. Oh, God, you haven't gotten to the back page. But you made sure all these answers are what you wanted to be? Yeah, that's good.
Turn in the test review on Google Classroom for the last session.
Turn it in and comment on it. Well, it's going to be half credit, but that's okay. It's yeah. Just comment on it, because KJ, then I get an email and I'll go fix it.
They were coached.
Viewpoint for Sheldon and Cass are. It's cool. See ya. Oh, guys, we're good. 2/70/51 divided by 3. She was